So how is it different than what we've been doing? Well, now we're going to be looking at elements and atoms and molecules and ions, not in the sense of what forms them or what types of forces of attraction hold them together, but very numerical properties like their masses and how they combine and what are the ratios they combine in. The first chapter, and that's in 2 weeks, right? Chapter 4, we're going to just deal with calculations involving just the chemicals themselves, not necessarily chemical reactions, all right? We want to be able to talk about how we quantify a group of atoms. How do we count them out? Atoms are phenomenally small things, and if we were to try to count them individually, we would be dealing with billions and billions and billions of atoms just if we were dealing with a small little amount of a chemical in the palm of our hand. So we need to be able to mathematically quantify these things so that we can talk about them and make sense of them, okay? The first thing we're going to deal with is a very simple start. Chapter 4, Quantities, Chemical Formulas. Just don't write down that first part. You've already wrote down the title. You know that we're going to be dealing with quantities. Chapter 4 is formulas themselves. You can start writing down by dealing with the chemical formula. What we want to deal with is just a chemical by itself. We don't want to deal with reactions yet. That's going to be the next chapter. So let's just talk about how we deal with the formula, what does it represent numerically, and how can we do calculations with that. So a quick little definition, and I think this is pretty straightforward stuff, but sometimes I don't have students write this, but I think this is good to write. So what do we find in a chemical formula? Well, we find the element symbols, and we find the subscripts. So a couple of examples. Number one, what does the formula indicate? The elements found in the entity of the substance, the ratio in which the elements must combine to form that entity. I'm going to define entity here in a moment. For now, let's just do a little example here. So if I'm talking about something like CO2, it means that we have a carbon to oxygen ratio of 1 to 2. It means that there is 1 carbon found in each carbon dioxide and 2 oxygens found in each carbon dioxide. We know from our previous experiences that these are 2 oxide ions because they've lost their electrons or gained their electrons. In this case, oxygen has gained 2 electrons, makes it -2. But in terms of their atoms, it's a 1 to 2 ratio. We can have a different compound, in this case carbon monoxide, and that's a 1 to 1 ratio in terms of their atoms. And it's this ratio that determines the properties of those substances. If the ratios are different, it's a different substance. We know that. I'm going to jump ahead a little bit here. Some of this stuff that's coming here is good information to remember, but it's not necessarily important, right? We've already talked about the law of definite proportions. We talked about that at the very beginning when we were introduced to Dalton's atomic theory. And this kind of comes from Dalton's atomic theory. We could have went from there right into this if we knew the formulas and knew the names of things, but we had to learn those formulas and names first. It essentially states that a specific compound always contains the same elements in a certain definite proportion. Now, back then it was by mass. We now know that the proportions are by atom type, right? In this case, it's 1 atom of carbon to 1 atom of oxygen. But that's how scientists would have identified substances in the past. They would have used that ratio of the masses. Now, the atomic mass. Let's not write this down. Let's write down atomic mass. No, we'll write the whole thing. We'll write the whole thing. It's not a bad little review of stuff. We've already been introduced to atomic masses. We talked about them in terms of their isotopes, and then we kind of left that. And actually, that was probably the last time we did any math on a test. Now we'll be doing lots of math. Again, it's a little disjointed. It would have been great if we could have continued on at this point from atomic mass to doing our calculations, but we needed to learn how to do the names of things and formulas and stuff like that. So when you're done that slide, you can get your periodic table out, because that's definitely going to be your friend from here on in. Number one, you use it to get formulas, obviously. Crossover method. You need the ions on the back sometimes. But now we're going to be looking at the mass numbers. Again, the unit that we use is U. It's a lowercase u. It represents 1/12 the mass of a carbon atom. And that's just a reference point. That's just what scientists have deemed to be 1 U unit. They just defined it that way. And a U is a very small mass. We'll talk about what that mass is in a moment. But right now, we'll just deal with the fact that it's a tiny mass, 1 U. So if we were to look at some examples, and don't write this down, I'll show you how to write this down. But if you were to take a look at sodium on the periodic table, you'd see 22.989, and therefore the mass is going to be 23.0 U, because when we get our masses off of the periodic table, I want you to round to 1 decimal. That's accurate enough for us. So here's the way I write it down, and you can write this down, e.g., all right? If I'm asking you for the mass of sodium, if you need the mass of a sodium atom, now I use a particular notation when determining my masses, and that's because that's the way that my teacher taught me in high school how to do it this way, and I've carried that all the way through when I do calculations. And it comes from when you start dealing with compounds. I like to put an arrow underneath the element like this. I then go to my periodic table. I notice that it's 22.98. I look at the second decimal, and I round it up. 23.0 U. All right? Instead of using the iron as an example, well, actually, iron's not a bad example here. I'll just write it down here as well. Fe. Again, I like to put the arrow underneath it. And if you're looking at Fe, 55.84. And notice there that it's 4. I don't care that it's 4, 5. I'm not going to round that up to a 5. I'm looking at the 4, and that's staying as 55.8 U. All right? So we're just using regular rounding. Let's do one more example. Let's do Mg. You guys find Mg. Tell me what the mass of magnesium is to 1 decimal place, rounded appropriately. Yeah, Emily, what do you got? 24.3? I got to check. I'm not sure. 24.3 U. So looking at magnesium, 24.30. That stays 24.3. Are we okay at finding the masses and then rounding to 1 decimal? Okay. So elements are pretty straightforward. But what if we're dealing with something like a compound, whether it be ionic or covalent, or maybe even an ion? The mass in U of one entity of a substance. Let me give you some examples of some entities. We're not going to find the masses of these right now, but I just want to define entities because we keep talking about these entities. Entities are any of these little tiny things that we deal with when dealing with chemistry. So an example of an entity could be something just like Na. If we were to describe Na, what would you describe Na as being in terms of small little chemical things we deal with? Yep. It's an atom. Has no charge. It's just an atom. I could have something like this. I could have Na plus, or maybe I could even have CO3 minus 2. What would that entity be called? Yep. Yeah, those are ions. So when we talk about entities, we're really dealing with just the little chemical things that we deal with all the time. Ions. And another example could be H2O. What do we call H2O? Yeah, Janessa? Yeah, that's a molecule. Excellent. That's a molecule. And this is the one we always have trouble with. What if I had something like NaCl? What would we call that? Yeah? Water's a compound too, right? It's an ionic compound, but what did we call that smallest little piece of an ionic compound? It had 2 words in it. Yep, a formula unit. Formula unit. All right? So when we're talking about entities, I think just leave the desk there. Just bring me the test. When we're talking about entities, that's what we're talking about there. You can just put it right on the desk there. All right? Let's do some examples then. Find the formula mass of. So we want the mass of the entire entity. Well, what's the first thing I'm going to need before I can get the mass of that entity? Yeah, Chris? Yeah, and what do we call that when we're talking about a symbol that represents the number of atoms of each thing? What do I need? Yeah? I need a chemical formula. I need the formula. Formula for magnesium chloride. Yep. MgCl2. MgCl2. All right. Now here's where my little notation comes into play. If we're dealing with something like this, we need to kind of set up an addition of all those masses. I like to write it again like this. You'll notice now I can put 2 arrows. I can track down Cl. What's the mass of 1 Cl? Rounded appropriately. Dallas? 35.5? 35.5 times 2. I think we just did the Mg, right? 23.0? No, 23.3. 24.3. Losing my mind. 24.3. No times anything. It's just 1. You can then set up your little addition there. Let the calculator do all the work. You don't need brackets. You don't need anything. The calculator will do the bedness for you. 35.5 times 2 plus 24.3. Yep, Janessa? 95.3? 95.3 U. If you get the idea, blaze on through. Calcium phosphate, though, is a little bit of a trick. What is the formula for a calcium phosphate? Yep. CaPO4. We need some crossover action. 3 and 2. And so where am I putting the 3? 3 and 2. This one is to illustrate what happens when we deal with all these brackets and things. Mass of an oxygen. What is it? 16.0 would be rounded. All right. 16.0 times. How many oxygens are in that thing? Yep. Yeah, there's 8. There's 8. It is literally 4 times 2. There are 2 phosphates. Each phosphate contains 4 oxygen atoms, 8 oxygen atoms. So that's the skill we are learning on this example. Somebody have a phosphorus mass? What do you got? 31.0? 31.0 times. How many phosphorus atoms? There's 2. And calcium, 40.1, I think, right? 40.1 and times 3. And again, let your calculator do the work. No thinking involved. Times, plus, it'll do all the order of operations for you. What do we have? $310? Was it that big? 310.3? 310.3? 310.3 U. Atomic mass units. I'll go through the formulas with you, making sure, well, hopefully you can do that. Oxygen gas, formula? O2. Ammonium sulfate. Has someone done that one? Just to make sure everybody's on the same page. Ammonium sulfate. Yep. NH4 brackets 2. SO, never mind. I don't know the symbol for that. SO4, and that's going to be a 1, right? Because the NH3 is 1. You guys go ahead and do those. This sheet has some extra practice problems that I'm going to be assigning as I go along here. What do we have for do we have for O2? Yeah, Janessa, what do you got? Just give me the total. Sorry? Oh, 15.0? I'm hoping it rounds to 16.0. 16.0 times 2, 32. And you know what? I don't want to see all the numbers. What do we have for an answer? What do you got, Dallas? 132 point, sorry, 0.1. You? Do we like that? We got support on that? All right. So getting the formula mass is a pretty straightforward thing. We need the formula, and then we just need to add up all those masses. As you can see, we could get it to far more significant digits than just 1. But for an introduction, 1 is good enough. We'll worry about the rounding business when we get into more complicated calculations, and I'll teach you how we round appropriately when we get to, to doing other more complex stuff. So this is good right here, and I'm not going to bother with that one. Okay, so what I'm going to do now at this point, on that sheet that I just gave you, I'm going to assign the first question or the first section that says complete the formula mass for each. So you'll notice that you've got a whole bunch of them right there where it says formula mass calculations. Yes? You guys didn't get it? Did it not get back far enough? All right. So at this point, I'm only going to let you work for about 5 minutes, and then I'm going to introduce you to something called the mole, all right, which is going to be the next step of how we count this stuff. And actually, at this point, you guys can put your stuff away, get your periodic tables out and that, and then I'll give you your test, and we can get started on that.